All right, today's lesson is 5.1, day 2. Today we're going to talk about angle bisectors. Yesterday we talked about perpendicular bisectors, so we're just going to group them all into one lesson. So go ahead and take a moment to pause and write down your objective and fill in your notebook information. All right, before we dive in, we're going to review a couple of things. We're going to first review what an angle bisector is. We learned this a couple of units ago. An angle bisector is a line ray or line segment that divides an angle into two equal smaller pieces. So if you're looking at the diagram on the right, the angle bisector, the blue angle, is being bisected by the red segment, which means that angle A and angle A have to be the same measure. For example, if the big angle started out being 50 degrees, the bisecting would make each of the angles 25 degrees. They both have to be the same measure. All right, and just a little FYI, because we'll be using this little piece of information when we talk about angle bisectors. The shortest distance from a point to a line is the length of the perpendicular segment from the point to the line. So I could pick any old point and line. So I'm just going to draw my own right there, and I'm going to add a little point right above it. If I wanted to find the shortest distance from that point to that line, the way that I would do that is to drop a perpendicular, and that would give me the shortest distance. For example, if I drew a line over here, that's a little bit longer than the other segment that I drew. So just FYI, the shortest way you can get from a point to the line is to drop a perpendicular to it. Angle bisector theorem. If a point is on the angle bisector of an angle, then it is equidistant from the sides of the angle. So let's talk about what that means. If this blue ray right here is an angle bisector, and I know that it is because these angles are marked as congruent, and this point lies on that angle bisector, then if I drop a perpendicular from here to here, and a perpendicular from here to here, these two segments would be congruent or equidistant from the side of the angle. So the distance from the point to the side of the angle to this side is equal to the other point to the midpoint on the other side. That's the angle bisector theorem. The converse of the angle bisector theorem says that if a point is in the interior of an angle and is equidistant from the sides of the angle, then it is on the angle bisector. So what that is saying, that if the reverse is true, if I have a point that is on a line and the distance from here to here is the same as the distance from here to here, then this point lies on the angle bisector. So let's write that on there. Lies on angle bisector. So if this is all true, then the drawing on the right, then I know that these two angles are congruent because it is on the angle bisector. All right, so let's put this to use a little bit. I can see from my drawing the red markings indicate that I have congruent angles, which means that AC, the ray AC, is the angle bisector, which also means if that's the angle bisector and these are 90-degree angles, that these two segments have to be congruent. Therefore, if BC has to be congruent to CD, and CD I can clearly see is 7.2, so BC also has to be 7.2. That's not so bad, huh? All right, we want to find the measure of angle EFH. So I'm right away, I'm going to go find my angle EFH. So EFH H. That's the angle I'm looking for, this guy right here. All right, I'm given that the measure of EFG is 50. So the measure of the whole thing is 50. All right, well, I can see that I have a couple of 90-degree angles, and I can see that I have a couple of congruent line segments, which means that this point here, this point H right here, is on the angle bisector. So if the whole angle, if this whole angle is 50 and is being bisected, that means each of the smaller angles would have to be 25. All right, I need to find the measure of angle MKL, which is this guy right here, MKL. So again, I can see that I have an angle bisector situation going on just by these markings that are here. This is congruent to that, and I've got some 90-degree angles, which means this has to be on the angle bisector. So they're giving me an expression, an algebraic expression for this angle right here, and also one for this angle right here. Well, I know that those two angles have to be congruent, so the expressions have to be equal to each other. So I'm going to set that up as 3a plus 20 equals 2a plus 26. Subtracting 2a from both sides is going to leave me just an a. And subtracting 20 from both sides leaves me with 6. Okay, let's be careful now because that's not what the question asked me to find. The question asked me to find the measure of angle MKL. So I have to go back, and in my measure of MKL, that's this guy right here, I have to plug in my information. So 2 times 6, plugging in 6 for A, plus 26 is going to give me 12 plus 6, or plus 26, I'm sorry, which is equal to 38. So the measure of angle MKL is 38 degrees. All right, finding the value of X, kind of a similar situation, except now that we're talking about side lengths. So I'm seeing that these two angles are congruent. I'm seeing that these two sides are congruent and that these are 90-degree angles. So that means this is on the perpendicular bisector. So those segments, the lengths of the segments have to be congruent. So I'm going to set them equal to each other. And if I subtract 6x from both sides, that's going to give me a negative 1x over here. And my negative 5 stays. And dividing both sides by negative 1, that's just going to leave me x is equal to 5. And I think I'm done here because all it did is said find the value of x. It didn't say anything about finding the line segment, so I'm done. All right, I think this is the last one. Similar situation, I've got congruent angles. They gave me two measures for each, or a measure for each of the angles, and I know that because that is an angle bisector, that those segments or the angle measures have to be equal to each other. So I'm going to go ahead and set that up. Solve my equation by subtracting 4x from both sides. I get negative 1x on the left. Subtracting 5 from both sides, I get negative 11 on the right. And dividing both sides by negative 1, I get x is positive 11. And I have satisfied what the question has asked. All right, if you were not here today, we did a class worksheet, so make sure you ask for that when you come in tomorrow. And also the day 5.1 day 2 homework is due tomorrow. You can find that online. See you tomorrow.